Welcome to the second video in this short series on creating a die set. We recommend you watch the videos in order, so go to the first if you haven't seen that one yet. In this video, we will add values into the setup dialog, which we will then link to the work that we did in the first video. We wish to thank you for your interest shown in Cimatron and hope you will search out other videos in this series. Open the Setup window by clicking Tools, then Setup on the top menu. We will create a folder and name it Overall Sizes. This will control features of the die shoe, such as the overall length and overall width. Once we have set this up, we can come back and add data for the coil, the die shoe thickness, and more. This is our recommended methodology, but if you prefer a different way to do this, the system can accommodate that. We have added a variable for the length and one for the width. We will leave the values at 0 so we can highlight the mistakes that are possible and then how to work around them. If you remember from the first video, we want to link everything to the die side. So click the length dimension and open the setup table from this button and make this dimension equal to length X. In this case, you can see the text is red to indicate a fault. The die shoe cannot have a 0 length. This is the first thing to note. When building the setup, put a nominal value for each item. For now, let's put 250 millimeters for the width and 600 millimeters for the length. These are different values than those we used to construct the die set for a good reason. Now when we link the length dimension from 500 to the 600 value, we know the relationships are working because the die shoe and the punch shoe moved. That's what we're looking for. As we go through, when we put a value in, we can verify that the relationships are in place. So now let's follow that same principle with the width. Now let's create another variable. Let's create a new setup value and name it start line. Normally, start line will be used to describe something different. For this exercise, it will be where the strip will start in the die set. In the last video, we put all the coordinate systems in a single column at 50 millimeters, and that's going to be our start line. Let's link that now. Working on the die plate first, double-click the component, click the dimension, click the Setup button to open the dialog, double-click the item in the setup, and click OK. Let's repeat that for the punch plate. Now if we change the setup values, we can see everything moves. Now we will create the next setup value. On the Strip Layout tab, we have width, length, and height. These values are linked to the strip. Let's enter values for these, and then we can start using those values in our formulas. We'll use width 225, length 750, and both heights set to 15. So click the General tab and edit the width Y value. Change the type of value by selecting Formula from the drop-down. We have everything that we need to make these changes. Go into the Strip Layout and link to the Strip Layout width. We will add in a value for spacing on either side. You could create a new variable in the setup for an overhang value and then use that in the formula in the same way as we did with the start line. Edit the length, change the type of value by selecting Formula from the drop-down. Here we're going to use the start line value. Type a plus symbol. Select the strip layout length. Press the plus key again. And the start line value. This now means we have the total length of the strip with the same margin at each end. These formulas will mean that any time the length or the width of any strip is changed, the shoes will be in the center because margins will be added equally to each side. Now let's work on a very important part. We'll create a folder to hold the die material sizes. And we will only create entries to control the die plate width and length. This is because the thickness will be specified later in a different folder holding all the stack heights. So here are the X and Y variables. Let's set up the formulas to control them. We will start with the width. I want to mathematically calculate what that value is going to be, so I need to use a formula. Select the width from the Strip Layout tab. We know the die plate is going to use that width. We don't know the length yet, so I will need to adapt that as I work. I could leave that as a value, but I want to establish some parameters for control, so we will use a range. We know we don't want to have a plate bigger than any set length because it won't fit on my wire EDM, so set that as the maximum. 2. Value. And set the minimum at 100. We can set a step distance for adjustment. We'll use 10 millimeters. Now let's tie it to the dimensions on the die plate. Click the length and click the Setup button. Attach it to the Setup die plate length. Both the die plate and the backup plate changed because of the relationship we created when we set those up. Click the width and click the Setup button. Attach it to the Setup die plate width. So far we can see the underlying relationships are holding nicely. For this demo, we will set the punch plate to be the same as my die plate. We can tie these dimensions in as well, but we shall tie them to the setup and not directly to the punch plate. Or you could create a new pair of variables for these dimensions and link them to the die plate width and length in the setup. This would make it easier to edit them separately later if you need to. Don't forget to link in the length dimension. Now if one of these two values is changed in the Setup Die Sizes folder, both the plates will update. Notice the punch backup plate has moved with the punch plate. You can see that when you're creating variables in the setup, it's best to work on one thing at a time and make sure it works before moving on to the next. Alright, let's create a new folder called Stack Heights. I know that to build my strip layout, I will need the coil thickness. That will be the thickness of the material. When we were working in forming, we used a function called die skin that measured the thickness of the coil. That value is visible in Setup on the Strip Layout tab. To link it, add a nominal value. Now we can link the height of the plane that we made for the stripper assembly in the first video to this thickness value in Setup. In the Features window, double-click the main stripper plane to show the plane height dimension. We can now use a formula and link the dimension to the strip layout thickness. Finally, we must link our setup variable to the strip layout thickness value. From now on, when we drop this die set on a strip, it will use that value. Now let's deal with our stripper sizes. We need to ensure we can control the XY dimensions of the plates in Setup. Create another folder to hold the stripper sizes. Add variables for the width and length. Then we can make the assignments. Create a formula on our stripper length. To link these up, pick the length that we already have for the die plate and attach that to the stripper plate. This means the die plate length variable will control the sizes now for all three of the main plates. Zoom in on the stripper and find the appropriate dimension and set up the link to it and accept. Thank you for reviewing this presentation. Look for our next presentation to follow, which will be talking more about die design.